You lie beneath the stars, their distant flicker echoing the hush in your body. Tonight, your mind slips between constellations, wondering what lies beyond. Out there, past the sky's curtain, are worlds that orbit suns we cannot see. Let's begin with the quiet question that started it all. Are we alone? You lie still. The night is quiet now. Even the thoughts in your mind begin to soften. Above you, the sky stretches open, a deep velvet dome stitched with stars. They flicker gently, not in chaos, but in a rhythm so ancient it feels like breath. You feel the pull of wonder, slow and steady, like a tide rising behind your ribs. There is something about the night sky that awakens a part of you not often used in the noise of daylight. A part that listens more than it speaks, a part that reaches, and so you look up. 1,000 tiny suns greet your gaze, each one unimaginably far, yet somehow intimate, like memories you never made. You know these lights are not just decorations in the sky. They are real. They are distant world suns, burning steadily through the emptiness. And for every star, there may be planets. You breathe in slowly, and the thought settles. The universe is vast, almost immeasurably so. If you held a grain of sand at arm's length, it would cover a patch of sky filled with thousands of galaxies. Not just stars, not just solar systems, but entire galaxies, each with billions of stars. Each of those stars with their own families of planets. You are small, yes, but not lost. Because tonight, you are not trying to measure yourself against the universe. You are simply floating in the quiet question that has followed humankind since we first looked up from the warmth of a fire. Are we alone? For thousands of years, this question lived in stories and myths. We imagined gods in the heavens, messengers in the stars, or mirrored Earths behind the moon. We drew maps in the sky, turning chaos into constellations, finding meaning where there was once only awe. But only recently, in the last heartbeat of cosmic time, have we begun to truly look, not with just our eyes, but with instruments more sensitive than any sense we possess. Telescopes that pierce the darkness, not to see what is beautiful, though much of it is, but to listen, to detect, to understand. The first planets beyond our solar system, exoplanets, were confirmed not long ago in 1992. Before that, we suspected, we hoped, we imagined. But it took the soft wobble of a pulsar, a kind of spinning stellar remnant, to whisper back at us. Something unseen was tugging at its rhythm, invisible worlds, influencing their star. And so the search began in earnest. At first, the worlds we found were enormous. Hot, heavy, chaotic giants, far from Earth-like. They didn't resemble home, but they were there, and that was enough. Like opening a door and finding the first footprints in fresh snow. You turn slightly, under the weight of this realization. For the first time in human history, we know that other planets exist, not just in our imagination, but in measurable space. And more than that, they are not rare. They are everywhere. Planets may be more common than stars themselves. Almost every star you see tonight likely has its own system, its own story, its own quiet arrangement of rocks and gases and possible oceans. Some planets may orbit so close to their stars that they glow with unbearable heat. Others may drift so far away that they are cloaked in eternal frost, wrapped in silence. But some, and this is what keeps us looking, may be like ours, with just the right balance of light and shadow, with gravity and water, with wind maybe, with life possibly. You breathe again, slower now. Your thoughts trail like comets through the vastness. It's humbling, this realization, that we are not at the center, that Earth is not the jewel of a singular creation. But it is also freeing, because if life could arise here, why not there? This is the gentle promise of astronomy, that truth and wonder can exist together. We don't lose magic by learning. We make new kinds of it. Imagine standing on a world that circles another star. Its sky might be a different color. Its gravity might tug at you differently. Its plants, if they exist, might not be green, but you would still recognize the idea of a horizon, of dawn, of looking up, and maybe, just maybe, someone there is looking up too. Your mind wanders now to the telescopes scattered across Earth and beyond. The Kepler Space Telescope, which quietly stared at a patch of sky and revealed thousands of hidden planets. The James Webb Space Telescope, peering into the very first light of the universe, and also toward nearby stars, analyzing atmospheres on alien worlds. These machines are not cold. They are extensions of longing, of our desire to know not just what is out there, but who. Because beneath the science, beneath the data and detection, the graphs and the algorithms, is that same flicker of curiosity that began when our ancestors first wondered what moved through the night. You are part of that lineage. As you rest now, your mind drifting in sync with distant orbits, you carry that legacy forward, not with noise or answers, but with stillness and questions. You imagine the veil between stars thinning. You imagine worlds behind it, maybe millions. Some empty, some wild, some newborn, and some Earth-like. But what does Earth-like mean? That is the next question. And to answer it, we must follow the faintest tremble, the gentle dance of light and gravity that tells us where to look. For when a star wobbles ever so slightly, something is pulling it. And maybe, just maybe, that something is a planet waiting to be seen. You drift toward a sun unseen, following the gentle tug of gravity's dance. Your senses soften as we trace starlight sways, the silent signs of hidden planets. Each wobble is a whisper, a cosmic signal that something small and distant is there. A new world, cradled by light, begins to speak. You float now in silence, deeper into the dark. The stars around you are steady, serene, or so they seem. But nothing in the universe is ever truly still. Even the stars move, ever so slightly, as if breathing in long, slow intervals. And if you watch patiently enough, with instruments that do not blink, you can catch the faintest of gestures, a gentle sway, a shift, a wobble. This is not chaos. This is choreography. The wobble of a star is a clue. Something unseen is pulling it, softly, rhythmically. A planet, perhaps small, perhaps rocky, is wrapped in a gravitational bond with its sun. It doesn't shine, not on its own, but it reveals itself by the way it tugs. You drift closer, not to see with your eyes, but to feel the precision of this cosmic tension. Gravity is quiet, but it is constant. It's the invisible string that holds moons near their planets, that binds planets to their stars, and stars to the great swirl of galaxies. It does not shout, it hums. And when a planet orbits a star, it pulls the star gently toward it, just as the star pulls back. The result? The star wobbles ever so slightly, a sway too small for the naked eye, but not too small for our instruments to detect. This is how many exoplanets were first found, not by seeing the planet directly, but by listening to the starlight's song and hearing that something was off, not broken, but altered, not random, but rhythmic. Astronomers call it the radial velocity method, but tonight we'll simply call it what it is, a whisper in the fabric of light. When a star moves toward you, its light shifts slightly bluer. When it moves away, the light leans red. This gentle blue-red breath, repeated over days or years, tells a story. There is something out there. It orbits me. It pulls me. We dance. You imagine it now, a golden star swaying in space, as if to music, not wildly, just a nudge, just enough to reveal that it is not alone. From Earth, we tune into that rhythm, like listening across a vast ocean with the most delicate of receivers. The change in light is impossibly small, a shift in color finer than any hue your eyes can distinguish. But it is there, reliable, like a heartbeat in the dark. And once we detect it, we begin to ask questions. How strong is the pull? That tells us how massive the planet might be. How fast is the cycle? That reveals the length of its orbit, its year. How consistent is the wobble? That shows us the stability of its path, the grace of its motion. From these tiny details, a world begins to take shape in your mind. It may be a gas giant, enormous and swirling like Jupiter, or it may be small and solid like Earth. We cannot yet see its oceans or mountains, but we sense its presence. And presence, in this quiet search, is everything. You rest in this thought, the idea that so much can be known from so little, that a tiny gravitational tug, barely more than the weight of a feather, can ripple through light across trillions of kilometers and reach us here on this small, turning Earth. It reminds you that the universe is not loud. It is patient. And when you listen with care, its secrets unfold slowly, like flowers that only bloom at night. More than 900 planets have been discovered through this method alone. Some orbit stars like our sun. Others circle red dwarfs, smaller, dimmer, longer-lived. One by one, these hidden worlds emerge from the background noise, and each one is a possibility, a reminder that planets are not rare, that systems like ours, with stars and orbits in balance, may be the norm, not the exception. You picture a distant solar system now, unseen by any human eye, but known by the wobble of its star. Maybe it has one planet, maybe many. Maybe one of them is quiet, blue, and fertile. Or maybe it is something stranger, a world of ice and steam, or a place where storms stretch for centuries. We don't know, but we know it's there. And knowing is the first invitation. You exhale slowly and let that knowledge sink in. We are not merely guessing anymore. We are measuring. We are reading the subtle rhythms of light, translating them into mass and motion and potential. Each wobble, each repetition adds another thread to the growing tapestry of discovery. And even though the stars feel fixed and eternal, we now know that they too are moved, gently, continuously, by the planets that orbit them, as if every sun in the universe is also listening, also feeling the pull of connection. You float once more, not toward the stars themselves, but toward their unseen companions, the planets that pull, the planets that remain hidden until their gravity gives them away. And now you wonder, what if a planet doesn't tug? What if it hides by passing in front of its star, casting a tiny shadow instead of pulling with force? What if we find it not by motion, but by eclipse? The next clue waits, not in the wobble, but in the brief dimming of light. A star dims ever so slightly, not from sleep, but from the passing of a planet. As your breath settles, imagine a faraway Earth brushing past its sun. Its silhouette speaks volumes in silence. Shape, size, rhythm, possibility, and in that shadow lies hope. You drift deeper now through the hush of space. Behind you, the gentle wobble of starlight fades into memory, a soft signature of something hidden, pulling in silence. But there is another way planets reveal themselves, not through movement, but through shadow. You float near a star. It is steady, golden, humming in its own quiet language of light. This star, like so many others, seems constant, unwavering in its brightness. But then, something changes. The light dips, not sharply, not dramatically, just a brief, graceful sigh in its glow. That dip is everything. It is the passage of a planet, a world crossing between its star and our watching instruments. From so far away, we cannot see the planet itself, but we can measure its shadow. This method, tender and precise, is called the transit method. And like so much of astronomy, it is an act of patient noticing. You picture it now, a distant star, its light like a candle burning beyond reach, and then, slowly, a planet glides across, casting a tiny eclipse. Not a total blackout, but a delicate reduction, a brief moment of dimness. It may last only a few hours, but in that time, a world tells us its story. The amount of light it blocks reveals its size. The timing of the dimming gives us its orbit, how long its year is. The shape of the curve, how quickly the star darkens and brightens again, can hint at whether the planet moves in a tight circle or a stretched oval. You rest in this elegant truth. Even a shadow can teach us. This is how we found thousands of exoplanets. Kepler, the space telescope named for the 17th century astronomer, watched a single patch of sky for years. It stared, unblinking, at over 150,000 stars, waiting for the smallest dip in brightness. And the dips came, one after another, in patterns too regular to be coincidence. Each dip was a whisper. A planet has passed. Some stars showed one planet, others revealed 2, 3, even 7. Entire families of planets circling their suns in delicate harmony, each orbit timed like notes in a cosmic chord. You let that music play in your mind. Planets passing, light dipping, returning, again and again. The beauty of the transit method is in its simplicity. You don't need to see the planet directly. You only need to notice when the light wavers. But the elegance hides a challenge. Not all planets transit from our point of view. They must line up just right. Their orbital plane perfectly matched to our distant gaze. It's like trying to watch a coin pass in front of a flashlight, but only if you're standing in the perfect position, far, far away. And yet, even with this narrow alignment, we've found thousands. Many of them are too hot, too large, too close to their stars. But some are smaller, temperate, with orbits not unlike Earth's. You pause with that thought. Could one of them be like home? To find out, we must read more than shadows. We must examine what happens when light filters through a planet's atmosphere, if it has one. As the planet transits its star, some starlight passes through its outer gases. That light carries fingerprints, tiny chemical clues written in color. Our instruments can pick out those clues, detecting the signs of water vapor, carbon dioxide, methane, even oxygen. You breathe in slowly and imagine another world exhaling into starlight. Its air mingles with its sun's glow, and from light years away, we read its composition, like reading tea leaves through a telescope. And sometimes the data gives us pause. Hints of clouds, hints of water, hints of balance. No proof yet, but possibility. These are the soft signs that keep us watching. The transit method does more than show us planets. It invites us to linger, to wonder, to listen harder. Some planets orbit small stars, dimmer than our sun, but more common. Red dwarfs glowing faintly. Their planets pass more frequently, making their shadows easier to catch. And among them, we've found Earth-sized worlds, some in their stars habitable zones, not too hot, not too cold, where liquid water could exist, where something, even something simple, might grow. You picture it now, a pale planet passing across a soft red sun, its light dimming just a breath, its presence known only through rhythm. We may never see that planet with our eyes, but we know its heartbeat, and that's enough to keep us searching. As you drift further into rest, you feel the gentleness of this science, its reliance on patience, on noticing what changes slowly. Astronomy is not about immediate answers. It is about learning to see what's always been there, to hear the music behind the silence. And when we listen closely, when we watch long enough, we begin to see not just shadows, but patterns, not just dips, but potential. And so you ask quietly, not to demand an answer, but to plant the question like a seed. If a world orbits in the right place, could it support life? Could it hold oceans, winds, rain, perhaps even a breath like yours? To answer that, we must journey into the soft zone, the gentle middle distance from a star where warmth lingers and water waits.